Homework 7, Combinations of Functions, Video 2. In the next few videos, we're going to talk about how to find the domains of functions, dependent upon how those functions are structured. For example, our first type of function that we're going to look for the domain of is what's called a rational function. In math, the word rational means ratio of two objects, in this case, ratio of two polynomial functions. So in other words, a fraction. We've already encountered this in the previous video. We got to make sure the denominator is not equal to 0. So the domain of a rational function is all real numbers except solutions to the denominator equal to 0. I think I'm going to put a box around that for emphasis. The domain of a rational function is all real numbers except the solutions to denominator equal to 0. So for example, let's take the function that we saw in the previous video. F of x equals f of x equals 7 over x minus 4. If we want to find the domain, we have to first solve the denominator equal to 0. That's pretty easy. Add 4 to both sides, we get x equals 4. But be careful, that's not the domain. In fact, it's precisely what is not in the domain. So how do we describe the domain besides saying everything except 4? In the homework, you are going to be asked to write your domains in interval notation. So to write the interval for everything except 4, which is what the domain is all real numbers except x equals 4. How would you write that as an interval? Well, remember, an interval is just a description of a shaded in number line. If we were to draw a number line for all real numbers except 4, I would go to the number 4, remove it, so I'll put an empty circle there, and I want to shade in everything else. Well, I have two intervals shaded in. The interval on the left of 4 starts at negative infinity, goes all the way to 4, doesn't include it, so I use a parentheses. And the interval on the right side of 4 starts with a parentheses and a 4 and goes all the way to infinity. And just like before, if an answer is comprised of more than one interval, you can union them together. So if this were a homework question, this is what you would type in for your answer. Most of these types of problems are pretty consistent, pretty straightforward. They just come in different varieties. For example, the second function we have here is g of x equals x plus 1 over x squared minus 7x plus 10. So how do we find the domain? Well, we want to avoid the denominator equal to 0, so we have to start by solving that. Solve x squared minus 7x plus 10 is equal to 0. It's worth mentioning here that you don't have to focus on the numerator. The numerator in a fraction can be anything, so there are no restrictions imposed upon it. There's only restriction imposed upon the denominator. So how would we solve this equation? Oh, look, a quadratic equation. You could get out the quadratic formula if you wanted to, but I promise you, in any situation in this homework where you have to solve a quadratic equation, it will be factorable. But you could still use the quadratic formula. X squared minus 7x plus 10 will factor into x minus 2 and x minus 5. So if we set each of those factors equal to 0 and solve, we get x equals 2 and x equals 5. But be careful, that's not the domain. That's what I need to remove from the domain. So if we were to draw a number line and remove the numbers 2 and 5, and shade in the rest, we have 1, 2, 3 intervals. The interval on the left is parentheses, negative infinity, comma 2, close parentheses, union. The interval in the middle is open parentheses, 2, comma 5, close parentheses, union. The interval at the end is parentheses, 5, comma, infinity, parentheses. Every time you remove a number from the domain, you pick up another interval. Let's look at the last example. H of x equals 5x over x squared plus 1. It is a rational function, and to find its domain, we would take the same approach. We would attempt to solve x squared plus 1 equals 0. That is technically a quadratic equation, but it's a quadratic equation with only one x term, which means I can solve it by eventually using square roots. If I subtract 1 from both sides, I'll get x squared equals -1. And if I square root both sides, the square root will cancel the square. Don't forget the plus minus on the other side. And by definition, the square root of -1 is I. Wait a second. The only numbers that will make this denominator 0 aren't even real. So what does that mean? Well, the domain is all real numbers except these. If I were to draw a number line, we'll put 0 in the middle. Where is I and where is -I? The answer is they're not on that number line because they're not real numbers, and only real numbers live here. If the solutions to the denominator equal to 0 are not real, that means you do not have to take any numbers off of the number line. You shade in the whole thing, in which case the interval and the domain is parentheses, -infinity, comma infinity, close parentheses. In other words, the domain is all real numbers. I can put any number I want in here as long as it's real, and I'll never get a 0 in the denominator.